Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to describe how the first derivative of a function and the second derivative of a function, which is the derivative of the first derivative, how they relate to the graph of the function here. So what I've done here is I've drawn just a sketch of some function here, and we've got some points here that we're going to talk about on this. Point A, B, C, D, E, F, and that's probably enough. And what we're going to do here is we're going to talk about plus and minus signs of the function, its derivative, and its first derivative at all these different points. So first of all, the function values. Now you notice that every one of these points is above the x-axis that I have drawn. So every function value here is positive. I'm just going to go ahead and put those all in. Move on to the next part of the discussion. Now, first derivative. Now the first derivative, remember, tells you about slope, even in its correct way it's written out. F prime of x is just kind of shorthand, but the first derivative is dy dx, which is differential y over differential of x. And even think to algebra class how that should hopefully remind you of delta y over delta x. So the first derivative gives slope. And when the slope of a graph of a function is positive, it means the function is increasing, meaning kind of moving up and to the right. If the slope is negative, it means the function's decreasing. And if the slope is 0, the function is horizontal. So at point A, you'll notice that the tangent line has positive slope. I'm going to go ahead for a moment here and just temporarily put that tangent line in at point A in red. Roughly speaking, the tangent line looks something like that. So what that tells us is that the first derivative is positive, is positive at point A. Now, as I move over to point B, or actually just imagine moving over just a small amount here. As this point moves over towards B, let's say, the tangent line has decreased in slope. And if we go ahead and move the point over to B and look at the tangent line is basically 0 there. At least that was the intention when I sketched it. So it's important to realize not just that the slope is positive at A, but also that the slope is decreasing. Now, mathematically speaking here, that's a reflection of a fact that this function has a negative second derivative at point A. I'll go through and talk about point B here. Function value is still positive. The tangent line, I've already discussed this, has 0 slope at point B. Now, if we look at some tangent lines right around that point again, okay, here's the tangent line at B. And if I move over just to the right a little bit, maybe right there, looks like the tangent line might look something like this. You notice that the tangent line has still decreased. The tangent line now has a negative slope. So I should say the slope of the tangent line has now decreased. That's a reflection of the fact that the second derivative is still negative at that point, at point B. Now, point C, this is kind of a special point here for this discussion. Notice that, where'd my, there we go, that's what I wanted. Notice that the tangent line just before C might look something like this. But just after C, maybe something like this. The slope of the tangent lines are decreasing before we get to C, but now they're increasing after C. So the second derivative at point C is 0. So we have a negative first derivative. Point C, we have a negative first derivative at C, but a second derivative that's now 0. This point here, where the graph changes shape, and while I'm talking about shape, you'll notice that this thing's got this shape that's hard to describe without using what it's called. It's called concavity. On this side of C, this shape is concave down. Over here to the right of C, the function is now concave up. So the second derivative being 0 occurs where the function changes concavity. This point's called an inflection point. If we move over to D now, the function is still positive. The tangent line is slope 0. So the first derivative at point D is 0. As far as the second derivative is concerned, you have to ask yourself, what is the slope doing? Because again, the second derivative tells you what the first derivative is doing. The tangent line right before D has negative slope. The tangent line just after D has positive slope. Looks maybe something like this. So you'll notice that we went from negative slope to positive slope. And in fact, right at D, we have 0 slope. So the slope's going from negative to 0 to positive. The slope is increasing. As a reflection of that, the second derivative is positive at D. And again, you'll notice that this curve is concave up at D. If I move over to point E, oops, I got to go back and I want to get rid of those tangent lines, right, and then put my positive there. Okay, at point E, E is right here. Now, again, the slope is positive, so the first derivative at E, positive. We're going from concave up to concave down. That's another inflection point. Therefore, the second derivative is 0 at that point. Talk about point F. The intention of my picture was a slope of 0 at that point. So first derivative, 0. Second derivative. Now notice that this is concave down, meaning that the slope is decreasing. Very important to realize. The slope just before F is positive. The slope at F is 0. The slope after F is negative. So the slope is decreasing in that region as a reflection of that. Second derivative is negative at that point. So, understanding the relationship between a function, its first derivative, and its second derivative is a very important concepts for graphing. First derivative tells you slope. Anytime the slope is positive, it means the function is increasing. So some values right there. First derivative, definitely positive. Right there, definitely positive. Right here, definitely positive. Positive first derivatives. The second derivative tells you what the first derivative is doing. The graphical interpretation of that is concavity. When the second derivative is positive, your function is concave up. When the second derivative is negative, the function is concave down. So these points that I just x'd here, here, and here, this first one has a negative second derivative because we're still in that concave down region. This point right here, I guess I put it pretty close to the 0, but it's either the second derivative is either 0 at the inflection point, or if we're just to the right of it, maybe up here somewhere, it's concave down, negative second derivative. This point is very definitively concave up, so positive second derivative. So it's very important to be able to look at a graph, pick any point on it, and tell the plus or minus signs, the plus, minus, or zeros of both the first derivative and second derivative. And we also want to be able to take information like this and use it to help sketch graphs. So I think I'm going to just end this video here. Hopefully this video is reasonable for help demonstrating or describing how derivatives and second derivatives relate to a function's graph. Have a great day.